Okay, today we are going to see design of rectangular footing. The question is design suitable reinforcements for a column of section 300 mm by 500 mm supporting an axial service load of 1000 kilonewton. Design a suitable footing for the column. They gave the column size and the service load acting on the column. Okay, so for this column, we have to design a suitable footing. Assume SBC of soil is 200 kilonewton per meter square. Materials used are M20 grade concrete and Fe415 high yield strength deformed bars. Draw the cross section of the column and footing showing reinforcement details. Okay, so first step is data, given data. So they gave an axial service load 1000 kilonewton. In the question itself, they gave the service load acting on the column is 1000 kilonewton. This 1000 kilonewton only transfers to the footing also. Size of the column is 300 mm by 500 mm. In the question itself, they gave 300 mm by 500 mm is the size of the column. Okay. Save bearing capacity of soil is 200 kilonewton per meter square, and the materials M20 and Fe415 bars are they gave in the question itself. So step 2 is ultimate stresses. So characteristic compressive strength of concrete, that is FCK, is equal to 20 Newton per mm square. Okay, Fy is 450 Newton per mm square. Okay, these values are also given in the question. Next, step 3 is the main column reinforcement. Okay, so this is the actual design from this step 3 only. We are starting design. Step 1, step 2, and all the data they gave in the question itself. So step 3 is main column reinforcement. So factored load on the column. First step is factored load on the column. Okay. Actually, they gave the service load acting on the column 1000 kilonewton. So factored load means into we are multiplying by 1.5. So 1.5 thousand is equal to 1500 kilonewton. Okay. So after calculating the factored load, next we are calculating the load. Okay. For column axial load acting on the column, we are having a formula. Okay, it is given in the code book IS 456 2000 in class 39.3. We are having this formula P is equal to 0.4 FCK into AC plus 0.67 into Fy into ASC. Okay, so ASC is the area of the concrete. Okay, AC is the area of concrete. We don't know the area of concrete. Okay, so for that we are using 0.4 FCK into AG minus AC. Okay, so AG is the gross area, total area. AC is the steel reinforcement area. If subtract the steel reinforcement area from the gross area means we'll get the area of concrete. Okay, so that only we are using this. Okay, so 0.4 FCK into AG minus AC plus 0.67 Fy AC. Okay, so in this we are calculating gross area of the section AG, where AG is equal to gross area of the section. We know the gross area dimension 300 by 500 mm. Okay, so 300 into 500 we'll get the gross area 15 into 10 power 4 mm square. Okay, so P is equal to, okay, we are substituting in the formula. P is equal to, P is the factored load 1500 kilonewton. So 1500 500 into 10 power 3 Newton is equal to 0.4 into FCK value is 20 into AG. AG is 15 into 10 power 4. 15 into 10 power 4 minus AC. Okay, we don't know the area of steel reinforcement. Okay, so minus AC plus 0.67 into Fy value 415 into ASC. Okay, so in this step we have only one unknown, that is ASC. Okay, so we can simplify this equation and we'll get the ASC. Okay, so on solving we get the ASC as 1111 mm square. Okay, so area of steel reinforcement for the column is 1111 mm square. So but minimum reinforcement is of 0.8 percentage of gross section. Okay, so therefore 0.8 percentage means 0.008 into cross section, not gross, cross section. Okay, so that is BD. So B into D, so 300 into 500, we are getting 1200. Okay, so, the minimum reinforcement itself is more compared to this ASC value 1111 mm square. Minimum reinforcement is more 1200 mm square. So we are taking this one. Okay, this value. and we are providing 6 bars of 16 dia. Okay, so we are providing 6 bars of 16 dia, and for this we are getting the reinforcement as area of steel reinforcement as 1206 square. Okay, so 16 dia bars means pi into 16 square by 4, we'll get a 201 square. Okay, so we are providing 6 bars, so 201 into 6 point something. Okay, so we'll get the area of steel reinforcement as 1206 square. Okay, for 1 meter length we are calculating. Okay, next step. Next step is ties. Okay, calculation of ties. So ties, stirrups. So both are same only, but technically we are naming the reinforcement, shear reinforcement in columns as a ties, and shear reinforcement in beams as stirrups. Okay, so stirrups are in vertical side. Okay, stirrups are in vertical form, and ties will be in horizontal form. Okay, so as per IS 456-2000, the class 26.5.3.2, we have certain norms for providing ties. Okay, I will show you that in a code book. Class 26.5.32. Okay, so this one. Okay, so in class 26.5.3.2 here. Okay, so pitch and diameter of lateral ties. Okay, the pitch of the transverse reinforcement shall not be more than the least of the following distances. Okay, so the least lateral dimension of the compression members, then 16 times the smallest diameter of the longitudinal reinforcement bar, or 300 mm. It out of these three values, it should not be more than the least. Okay, so it should be minimum. So 16 by 4 mm and 5 mm. Okay, so we are providing 6 mm diameter ties. Okay, here the diameter of the polygonal links. Okay, the diameter of the polygonal links or lateral ties shall not be less than 1/4 of the diameter of the largest longitudinal bar, and in no case less than 16 mm. They are mentioning it as wrong. Okay, 6 mm, not 16 mm, 6 mm. Okay, so diameter of the polygonal link or lateral ties shall not be less than 1/4 of the diameter of the largest longitudinal bar. Okay, so we are providing a 16 dia only. Okay, we are providing 16 dia bars only. So 1/4 of 16 means 4 but we are providing 6 dia ties. Okay, and in no case less than 6 not 16 6 So that only we are choosing 6 bar as a tie reinforcement. Okay, so after that, pitch of the ties. Okay, the pitch is the spacing distance only. For that also we are having in code book. Okay, so there are both three steps. The pitch of the transverse reinforcement shall not be more than the least of the following. Okay, so there are 3 points. Okay, so the pitch value should not be more than these three. Okay, the first point, the least lateral dimension of the compression member, the least lateral dimension of the compression member. So for our problem, the compression member, size of the compression member is 300 by 500 mm. Okay, in the question they gave, okay, size of the column is 300 by 500 mm. Okay, so the least dimension is 300 mm. Second point, 16 times the smallest diameter of the longitudinal reinforcement. Okay, so we are providing 16 mm dia bars only. So 16 into 16, so 256 mm. And third value is 300. So out of these three values, the least value is 256. Okay, so the pitch of the transverse reinforcement shall not be more than the least of the following. Okay, so shall not be more than the least of the following. So 256 is the least. Okay, out of these three, 256 the least. So it should not be more than 256. Hence, we are providing 250 mm. Okay, so the pitch of the tie is 250 mm. So hence adopt 6 mm ties at 250 mm center to center. Okay, so far we design main column reinforcement and tie reinforcement. Only two steps only we completed. Okay, so in main column reinforcement, first we are calculated the factored load. Okay, so multiplying by 1.5, 1500 kilonewton we are getting, and after that we are calculating the axial load in the acting on the column by using the formula 0.4 FCKAC plus 0.67 FIAC. Okay, it is in the code book IS 456 2000 class 39.3. So in this we are calculating the area of steel reinforcement and we are calculating the minimum reinforcement. Okay, so minimum reinforcement is more when compared to the calculated area of steel reinforcement. So we are choosing minimum reinforcement and we are calculating the we are adopting the so dia bar 16 mm dia bar, 6 numbers of 16 mm dia bar, and we are for that the area of steel reinforcement is 1206 mm square. After that we calculated the reinforcement for ties. Okay, ties is nothing but horizontal shear reinforcement. If we provide the shear reinforcement in vertical means that is stirrups. So normally stirrups in beams only. In columns we name it as ties. So next step is size of footing. Okay, the load acting on the column is 1500 kilonewton. We know that the load acting on the column is 1500 kilonewton. This already gave in the question itself. Then self weight of the footing. Self weight of footing is 10% of the load on the column. Okay, so 10% means 1500 into 10 by 100. So we are getting 150 kilonewton. Self weight of the footing is 10% of the load on the column. Okay, so 150 kilonewton. Therefore, total ultimate load is equal to, we are adding these two, okay, 1500 plus 150, and we are getting 1650 kilonewton. Okay, so after calculating total ultimate load, next we are calculating the footing area. Okay, so footing area is total ultimate load divided by 1.5 into 200. Okay, so this 200 is safe bearing capacity value. Okay, safe bearing capacity of the soil 200. Okay, so 1.5 times of 200. Okay, so we are getting footing area as 5.5 meters square. Okay, so the area of footing is 5.5 meters square. Still, we didn't calculate the size of footing, the width and depth and all. Okay, so by using the proportion of the footing area, the proportion of footing area is in the same proportion as the sides of the column. Okay, so we are designing the rectangular footing only. Okay, so the column is also rectangular. So we are using the column proportion for calculating the proportion of footing. Okay, so hence 3x into 5x. Okay, so the size of column is 300 mm by 5 mm, 500 mm. So we are using that proportion. So 3x by 5x is equal to 5.5. Area footing is 5.5. Okay, so 3x into 5x is 15x square. So 15x square is equal to 5.5. So x square is equal to 5.5 divided by 15. So on simplification, we'll get the x as 0.604 meter. Okay, So we calculated that X proportion 0.604 meter. Therefore, short side of the footing, that is 300 mm, here 3x. Okay, so 3 into X value is 0.604. So 3 into 0.604 is equal to 1.814 meter. So short side of footing is 1.814 meter, and long side of the footing, that is 5x, 5 into 0.604, we are getting 3.02 meter. So adopt a rectangular footing. We are rounding these values. Okay, we adopt a rectangular footing of 2 meter by 3 meter. Okay, so short side of the rectangular footing is 2 meter and long side is 3 meter. Okay, so after choosing the size of the footing, okay, next step is calculating the upward soil pressure at service load. Okay, so at service load, the load acting on the column is 1000 kilonewton. Okay, so 1000 divided by size of the footing is 2 into 3. Okay, so 1000 divided by 2 into 3, we are getting 167 kilonewton per meter square. This is the upward soil pressure, which is less than the SBC of the soil, 200 kilonewton per meter square. Hence, it is safe. Okay, so therefore, factored soil pressure is 1.5 into 167. Okay, so 1.5 into 167. So we are getting 250.5 kilonewton per meter square. So in Newton per mm square, it is 0.2505. Okay,